cryptography, and information hiding. She has contributed significantly to these fields with numerous publications to her name. Now, today, Dr. Tiwari will be delivering a session on the overview of cryptography and its applications, where she will take us through the critical role cryptographic players in the security digital information. Her insights will help us to better understand how cryptographic techniques are applied in various domains to safeguard data. So please join me in welcoming Dr. Namita Tiwari.
Thank you, ma'am. Should I start?
Yes, ma'am.
Yes. Am I clearly audible to all of you?
Yes, ma'am.
Okay, I'm sharing screen. Please acknowledge.
Yes, ma'am, you are audible.
Is the screen is visible?
Yes, ma'am. Ma'am, you are not audible.
Am I audible?
Yes, now. Yes, now.
screen is visible?
Yes.
Okay. Let me know whether now it is visible or not.
Yes, ma'am, it's visible.
Hello?
Yes, ma'am, it's visible.
It's visible?
Yeah.
Okay. So now it is visible in full screen mode?
No.
Second. I am resharing my screen.
Ma'am, your PowerPoint presentations are visible.
ओके यहाँ से चलो
यहीं से चलेगा स्लाइड
visible now?
Yes, ma'am.
Am I audible?
Yeah.
And visible? Screen is visible?
Not in full
Moving to
screen, but
next
in the
slide.
PowerPoint view.
Okay, so not in full screen. Now it is fine.
Ma'am, you're sharing the whole screen, no?
Yes. Even full
Ma'am,
screen
but it
mode.
is visible. It is okay.
Okay. So whether it is moving to next one,
Yes, ma'am.
able to
Ma'am, you can continue with the
move
slides
towards the
also.
next slide. Yes, yes, that is your is visible now in the next and next and next it is visible.
Yes, yes.
Okay, so I will start now. So good afternoon. I am Dr. Amita Tiwari, and my research area is information security in the related field. But today's topic is emerging trends in the cryptography and its application. So, madam, if anytime I'm not, my screen is not visible or I'm not audible, please let me know. Okay, can
Yes,
interrupt
sure,
me.
ma'am. Yes.
Okay, so whether in the field of information security, when we want to communicate to anyone else, the first thing that comes in the mind is the security. That whatever the message which we are sending to the receiver, it should be received by the intended or legitimate person. So the common solution to this problem is the cryptography, that we can send our message in the encrypted form, and the receiver will receive the message in the encrypted form, and the receiver will
Ma'am, you are not audible.
there. मैं तो शायद आपका नेटेड था नेटेड था Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, sorry for the interrupt. Sorry. It is visible.
Yes, ma'am.
Okay, so we are discussing about the major three component of the network security. So there are three major components of network security: attacks, mechanism, and the services. If you're talking about the attacks, so there are different type of attack. Broadly, we can classify the attack into two category. One is cryptanalytic attack and other is non-cryptanalytic attack. So let's start with the non-cryptanalytic attack. Basically, these are the security attacks. And there are three major points of security attack. One is client, other is server, and third one is the communication channel. So security attack can be broadly classified into two types: passive attacks and the active attack. What do you mean by passive attack? Passive attack means they are only monitoring the traffic flow from one end to the another end. They are not disturbing the traffic, but they are silently monitoring the traffic. They are analyzing the traffic. This is the passive attack. Whereas in the active attack, they are doing some modification in the attack while in the transmission mode. They can modify the message during the communication of the message. So different type of way in which the active attacker can perform the active attack, like the masquerading. Masquerading means to pretending like someone else. If they masquerade of one entity, hello, if they masquerade of some other entity and they are pretending like someone else. So this is the masquerading. That means attacker can pretending like the legitimate person. So for active attack, they can perform the replay attack, they can perform the delay attack, they can modify the messages during the transmission, they can add, they can delete the message content. And denial of service also a type of active attack. So in active attack, there are end result are perfectly visible and perfectly visible to the victim. But in the passive attack, the victim can is unaware about the attack. So this is the two major type of active and passive attack of the security attack, and it is known as the non-cryptanalytic attack. Say for example, if we are talking about the passive attack, so there is an interception. That means there is a Bob and the allies are the legitimate person, but the Darth is the active passive attacker. So he can silently observing or monitoring the traffic from the Bob to the allies, and he can able to read the content of the message from Bob to allies. I'm audible now. Hello.
Yes, ma'am, you're audible.
Okay. Let me know in between if I'm not audible or not, or my screen is not visible. Okay.
Yes,
So
sure, ma'am.
this is a pictorial representation of the passive attack, and this is the example of interception where the Darth is silently able to analyze the traffic. He can able to read the content, the message from the Bob to the allies, but he is not doing any modification in the attack while traveling from one place to another. So this is an example of passive attack. Another example of passive attack is traffic analysis. Darth is able to read the content of the message. Okay, so this is also a passive attack. He is only observing the traffic. He is not editing or he is not modify the content. So this is the passive attack. Now the active attack where the Darth is able to read the content of the message as well as he is trying to interrupt the traffic from Bob to the allies. So it is an example of active attack. Another example of active attack is the fabrication, where the Darth is able to read the content. He will modify the content according to him, and then he will retransmit the message to the allies. And allies is the victim who is not aware with the Darth. So this is the example of active attack. This is another example of active attack where Darth is intercepting the message from Bob to allies, and after intercepting the message, Bob will sending the message again and again. That means he is used to replay the message to the allies. He is capturing the message from Bob to allies. Later on, he will replay the message to the allies. So this is an example of active attack. Active attack, another example of active attack is the modification. Whatever the message is Bob sending to the allies, if the Darth is able to intercept the message, first Darth will intercept the message. He will capture the message from Bob to allies. Later on, he will modify the message and then he will send the message to the allies. So this is an example of modification actually. So this is broadly an active attack. So these were some examples of the active attack. Now come to the cryptanalytic attack. Whatever we have discussed so far is the example of non-cryptanalytic attack. Now come to the cryptanalytic attack. So cryptanalytic attack, basically they attack on the algorithm, the mathematical property of the encryption algorithm, and they attack on the key that is used to encrypt the message. The attacker will attack on the key as well as the encryption algorithm. They exploit the mathematical and statistical properties of the algorithm. Whereas in the non-cryptanalytic attack, they are not attacking the algorithm, they are attacking on the services. So this is the cryptanalytic attack. There are different type of, there are 4 types of basically cryptanalytic attack. First is ciphertext only attack. Second, known plain text attack. Third, chosen plain text attack. And fourth is chosen ciphertext attack. So let's start with the ciphertext only attack. This is the diagram of ciphertext only attack where the allies is sending the message to Bob, and in between the communication, Eve is an attacker who is able to intercept the message from allies to Bob. Once Eve has intercepted the message, now Eve is only having the ciphertext. The ciphertext which Eve has intercepted from Alice to Bob. Now Eve will analyze the ciphertext and he will try to attack on that particular ciphertext on the encryption algorithm and in the key. And he will analyze and he will able to get the plain text back. So here in ciphertext only attacker is having only the ciphertext, not anything else apart from the ciphertext. That's why it is known as the ciphertext only attack. There are different type of ciphertext attack like the brute force attack, pattern attack, and the statistical attack. Brute force attack, as we know that brute force attack means the trying all possible combination of password and the encryption key or the login credential until they got the correct one. So this is the brute force attack. Brute force attack is also known as the exponential key search attack. Yeah, exhaustive key search attack where the attacker is try all the possible combination until he will find the correct or some meaningful message. So brute force attack is an example of ciphertext only attack where the attacker will apply the different type of keys and the combination on the intercepted ciphertext. Another is the statistical attack where the attacker will attack on the statistical properties of the language. Suppose we are having some message in the English like language and we have converted that English like language message into some ciphertext form. Are you getting my point? Suppose we are having some hello message that is in the English language and we are converting this plain text. Hello is in plain text and we are converting this hello into the ciphertext. So this is the property of English. So attacker will exploit the property of the language. Suppose if the attacker wants to exploit the properties of English, so how he will exploit the properties? In the English language that we know, the alphabet E has the highest frequency. Suppose we are writing in paragraph, so if we count the frequency, the alphabet E is having the highest frequency. Second highest frequency of A. So these are known as the inbuilt or inbuilt property of the English like language. So what attacker do? Attacker will exploit or attacker will attack on the inherent properties of the language. So if the attacker is attack on the inherent properties of the language, it is known as the statistical attack. Suppose if he finds some ciphertext, he intercepted some ciphertext and he will apply the statistical properties of the language. He will find the alphabets and he will replace the alphabets with E, the alphabet which is having the highest frequency. Are you getting my point? So this is the statistical attack. Are you getting my point? Are you audible? Am I audible?
Yes, ma'am.
Okay. So another type of ciphertext only attack is the pattern attack. Now, what is pattern attack? In the pattern attack, if we are converting some plain text into the ciphertext, there definitely it will make a pattern because we are using a key and the key is shared between the sender and the receiver. Fine. So that if we are using the key for encrypting the message, so in the encryption and the decryption process, the ciphertext will create a pattern. Suppose pattern means, suppose we are having an hello message, HELLO. This is the plain text message and we are converting this hello into the corresponding ciphertext. Suppose we have converted HELLO into some other word like XYZZW. Okay. So we are putting some other alphabet instead of the plain text alphabet. So attacker will attack on the pattern. Suppose we have put instead of A, we are putting D. Instead of D, we are putting F. So here the pattern is 3. That means after the 3 place letter, attacker will know that they are converting the plain text into the ciphertext by replacing the 3 place letter alphabet. So this is how the pattern is created. So in ciphertext only attack, attacker will attack on the ciphertext only on the basis of different type of attacks like the brute force attack. In brute force attack, they are try all possible combination. In the pattern attack, they are finding the pattern. And in a statistical attack, they are attacking on the statistical property of the language. Another is the non-plain text attack where the attacker is having ciphertext as well as the attacker is having the previously pairs. Like in history or in database, if there are some plain text ciphertext pairs are stored, so attacker will use the previously stored pair of the plain text and ciphertext for analyzing the current ciphertext. So this is the non-plain text attack. Another is the chosen plain text attack, where the attacker will get the access of the computer of the sender, and from the computer of sender's computer, if suppose, say for example, attacker is having the access of the sender's computer, suppose he has stolen the credential, the login ID and the password of someone else, and after getting the credential of or login ID and password, the attacker will get the access of the sender's computer, where the sender's computer attacker will find the pair of plain text and ciphertext of his choice. So this is the chosen plain text attack. In the reverse order, chosen ciphertext attack, suppose the attacker is having the access on the receiver's computer. Suppose the attacker has stolen the credential, login ID and password of the receiver's computer. Attacker will attacker will have the access of the receiver's computer, and from receiver's computer, attacker will find the plain text and ciphertext pair of his or her choice. That's why it is known as the chosen ciphertext attack. So these were the four type of cryptanalytic attack. So far I discussed about the different cryptanalytic and non-cryptanalytic attack. That is the first component of network security. Second component of network security is the security services. Okay. So there are different type of security services are there, that the security services that the secure system is provide to user, like the authentication, access control, data confidentiality, data integrity, non-repudiation, availability. These are the major services. These are the major fundamental building blocks of the network security. Authentication is authenticated person can communicate to someone. Suppose I am the sender and you are the receiver, so we both can be the information security system giving the authority that communicating entities one of the claim have both origin authentication. That means the sender and receiver both are the authenticated person. What do you mean by access control? That means access control over the information, but in the right direction. This is the access control. Whatever is the information or resources, that should be accessed by the legitimate person, but in the right manner. So this is the access control. Next one is the data confidentiality. That means protecting the data from unauthorized access. Suppose I send message XYZ, that should be received by you in the form of XYZ. Are you getting my point? That XYZ should not be by XZ or Z by X. But sequence should not be modified. The content should not be modified. Okay, so there should not be any modification from sender to receiver. Whatever I am sending, it should be received in the same way by the receiver. So this is the data integrity, data confidentiality. That means protection of data from unauthorized access. Non-repudiation means if I am sending the message to you, after sending the message, I cannot deny. After receiving the message, you cannot deny. This is the non-repudiation. And availability, that means the resources and the information should be available to its intended user whenever it is required by the user. Suppose I am legitimate user of some information, or I am legitimate user for some resources. Whenever I require that resource and the information should be available. Am I audible? Am I audible?
Yes, ma'am, you're audible.
Why are you responding so late? Okay, so whether my screen is visible to you?
Ma'am, screen is not visible.
No, ma'am.
Screen is not visible. Is it visible now?
Yes, ma'am, it's visible.
So, are you getting me from the starting now? Any content have you missed so far? We have discussed. Is it visible now?
Yes, ma'am, it's visible.
Okay. If I'm changing the slide, is it visible?
Yes, yes.
Okay, fine.
Yes, ma'am.
So, okay. In continuation with the securities, please interrupt me whenever you are not able to see my screen. Okay. So, in continuation with the security services, this is the CIA triad. Have you heard about the CIA triad? This is the triad of the confidentiality, integrity, and the availability. So network security in its simplest term, it is a set of rules and configuration designed to protect the integrity, confidentiality, and the accessibility of the computer network. So that's why it is known as the CIA triad of the network security. So far what we have discussed about the attacks, we discussed about the services. Okay, now security mechanism. So the third major component of security, network security, is the security mechanism. There are different type of security mechanism are there. Like the cryptography is a security mechanism, steganography is the security mechanism, digital signature is the security mechanism, message authentication code is the security mechanism, and SHA hash functions are security mechanism. So different type of features designed to detect, prevent, and recover from security attack. How we can recover the attack, or how we can protect our information from the different type of attack. So by using the different type of methods, we are protecting our information from different type of attacks. So these methods are known as the security mechanism. So cryptography is one of the security mechanisms. By using the cryptography, we can protect our data. So what is the relation between the three major component? Whether it is visible, na?
Yes, ma'am, it's visible.
Okay. So far we have discussed about the three major component of network security: attacks, mechanism, and the services. Now we can see the relationship between these three components. Suppose there are different type of attacks. Okay. So for protecting different type of attack, we are using the mechanism and to provide the services to the user. Are you getting my point? So this is the relationship matrix between the attacks, mechanism, and services. Suppose there is an attack like the release of message content. Okay. So this is a type of attack, the release of message content. By using the encryption mechanism, we can protect our data from release of message content, and we can provide the service like the confidentiality. So this is the relation. Suppose there is an attack is the repudiation. Repudiation means suppose someone send the message, and after sending the message, if the person is denying from sending the message, this is the known as the repudiation. To prevent our data from the repudiation attack, we can use the mechanism like the digital signature to provide the services like the authentication to the user. So what is the relationship between among three? Repudiation is an attack, digital signature is a mechanism, and the authentication is a service. Getting my point? So this is the relation between the three components. So now come to the cryptography. Now we clearly know that cryptography is a mechanism that belongs to the mechanism component of the network security. Right? Cryptography is a study of secret writing, and it can be classified in the different type of classification on the basis of the key which is used by the sender and the receiver, where we can classify the cryptography into two parts, symmetric and asymmetric cryptography. Symmetric cryptography, where we are using only single key between the sender and the receiver, whereas in the asymmetric cryptography we are using a pair of key at the side of sender and pair of key at the side of receiver. Are you getting my point? So examples of asymmetric cryptography are the RSA, Algol, Diffie-Hellman key exchange. Elliptic curve cryptography is the example of asymmetric cryptography, whereas symmetric cryptography, DES, AES, these are the example of symmetric key cryptography. Further, we can divide the symmetric key cryptography into block cipher and the stream cipher. The example of block cipher, data encryption standard, DES, advanced encryption standard, AES. There is the stream cipher like the RC4. So this is an classification of the cryptography. This is the symmetric cryptography. So we can see the pictorial representation of the symmetric cipher model, where this is the plain text, this is the encryption algorithm, and by using the shared key, the sender will convert this plain text into the cipher text by using the key. The same key is used for the decryption process. Here the decryption algorithm will be used by the receiver by using the same key that is being shared between the sender and the receiver, and it will again convert the cipher text into the plain text. So this is the pictorial presentation of symmetric cipher model. If we divide the cipher on the basis of different methods, the cipher in the transposition. What do you mean by substitution cipher? If we are converting our plain text into the cipher text, if we are putting some other alphabet of the plain text, if we are replacing some numeric values, if we are replacing some symbol of the plain text, that means we are finding the substitution. Suppose we are having a message hello, HELLO, and instead of hello we have converted this hello into XYZZW. So XYZZW is the cipher text, HELLO is the plain text. Are you getting my point? So we are substituting, we are finding the substitute of the hello message. We totally the redundancy of some alphabet in the plain text that will definitely reflect in the cipher text also. Suppose in my plain text HELLO, there is a frequency of L 2 times. Okay, so every time L will replace by the D by using some algorithm. That means if the L will come 3 times in the plain text, it will reflect in the cipher text also. Every time L will convert it into the D. So if the plain text, if L will come 2 times, in cipher text D will come 2 times. So this is known as the one-to-one relationship. That means the frequency of the alphabet is will be reflected in the cipher text also. So this is the basically vulnerability of the system. So how can we remove the vulnerability of the system? So by using the polyalphabetic cipher, we can remove the vulnerability of the system. Basically, polyalphabetic cipher is having to one-to-many relationship, right? If there is a repetition of plain text of some alphabet in the plain text, that will not reflect in the cipher text. This is the polyalphabetic cipher. So if there is a repetition of, suppose L, hello message mein, in hello, there is a repetition of L 2 times, it will not reflect in the ciphertext. Every time L will replace by some other alphabet. First time L replaced by the L, and second time replaced by the N. So this is known as the 1-2, and it overcomes the problem of the monoalphabetic cipher. These are the example of substitution cipher. Caesar cipher is an example of monoalphabetic cipher. Basically, Caesar cipher are the additive cipher in which we are adding some key value to the alphabet. Suppose in plain text we are having A. So uh, in ciphertext it will be replaced by D. So what is the value of key? K equals to 3. 3 place letter word will be replaced by the ciphertext. So here the key will be 3. That means we are adding 3 number to the alphabet. Suppose A is having number 1. So we will plus 3. We will do the plus 3. That means the D. D will be the ciphertext. So this is the Caesar cipher. Caesar cipher is also known as the additive cipher. Also on the name of the researcher, it is the name of the Caesar cipher. So basically, it is the additive cipher. One is the substitution cipher, and other is the transposition cipher. In transposition cipher, we are not changing the alphabet, else we are changing the position of the alphabet. Are you getting my point? We are not finding the substitute of the plain text. We are not finding the substitute of the plain text. That means if there is a hello message, HELLO, so we are not finding the substitutes. We are just reordering the alphabets in some pattern. We can change the sequence of the alphabet. Suppose HELLO, so we can do OLEHL. Are you getting my point? So this is the transposition cipher. That means we are changing the position only. We are not finding the substitute. There are different type of transposition ciphers are there. One example of transposition cipher is the Rel-Fence cipher. In Rel-Fence, what happened? In Rel-Fence, we write the plain text in the diagonal form. Okay. Suppose the message is meet. Okay. So we are writing this message in the diagonal form and we will read that message in the row by row. So write the message letters in diagonal and read the message by row. So this is the called of Rel-Fence method. That is a transposition cipher in which we are only changing the position of the cipher. In this example, you can see we are writing the message diagonally and we are reading the message row by row. Another type of transposition is the row transposition cipher, in which we are writing row by row and we are reading column by column. Suppose there is a message attack postponed until 2 a.m. Okay, this is the message. So we have written this message row by row, attack postponed until 2 a.m. So we have written the message row by row and we read the message column by column on the basis of the given key. The key is 3, 4, 2, 1, 5, 6, 7. So first we will read the third column. That means third means T, T and A. So you can see T, T and A is the first column. Second column is 4. So 4 APTM, APTM. So in this way, we will write the row by row and we will read the column by column. So this is the row transposition cipher in which we are not finding the substitute instead of plain text, but we are changing the position of the alphabet in some particular pattern. Okay. Another category is the block and stream cipher. So we can divide the encryption methods on the basis of the ciphers. One is block cipher, other is stream cipher. Block cipher, that means we are converting the whole block of plain text into the cipher text. The whole block of plain text into the cipher text. If there is a 64-bit block, that 64-bit block as a whole will be converted into the 64-bit block of ciphertext. Are you listening me?
Yes, ma'am.
Yes. So, my voice is clearly audible, na?
Yes, ma'am.
Okay. So say for example, if we are having a 64-bit block of plain text, so we are converting this 64-bit block of plain text into 64-bit block of ciphertext. So this is the block cipher. Whereas in the stream cipher, bit by bit conversion is there, a bit by bit conversion, or else byte by byte conversion is there. So stream cipher is a continuous process in which the streams are generated continuously. Okay. But block cipher is a process where we are converting a block of plain text into the block of ciphertext. So what is the difference between block cipher and the stream cipher? If we are talking about the speed, so no doubt the stream cipher will be fast because it is a continuous process. Continuously we are converting the bit streams and the byte stream to the ciphertext. So stream cipher are more fast. These are the faster than the block cipher. Whereas if we are talking about the security, so block cipher will be more secure. Okay, so this is the difference. So let's start with an example of block cipher. For this particular block cipher, I have taken an example of DES, that is the data encryption standard. It is the most popular and the common and very standard method of block cipher. If you belong to this field, so you will definitely know about the DES data encryption standard. So I have taken example of DES for the block cipher. So basically, in DES data encryption standard, there is a 64-bit block of plain text that is converted into the 64-bit block of ciphertext with a key value of 56. So for block cipher, for DES, we are taking 64-bit block of plain text, and apart from this, we are taking a 56-bit of the key. Okay. So this is the initial features of DES. Let's move towards its architecture. So I have taken an overview of this encryption method. So this is the overview of DES encryption method. DES is a block cipher. DES is a symmetric block cipher, and it is iterative in nature. It is iterative in nature. That means it is iterative in nature. That means there are 16 identical rounds. Round 1 to round 16, there are 16 identical rounds. By using the 16 identical rounds, the plain text is converted into the ciphertext. For each round, they are having a separate sub key. So there are 16 sub keys are there. K1 to K16 are the sub keys. So initially, we are taking the 64-bit plain text block that is converted into the 64-bit ciphertext block. Okay, and we are taking the 56-bit of key. From the single 56-bit of key, we are generating K1, K2, K3, K16s are the sub keys. For each round, one key is there. For round 1, there is a K1. For round 2, there is a K2. For round 16, there is a K16. Okay, so with parameterization of the key, we are converting this plain text block into the ciphertext block. If we go to the more in detail of the round structure, so for a single round, there are different operations are there, like the substitution, the permutation, the shift row, mix column, and the XOR functions are there for a particular round. So in this way, the 64-bit plain text block will be converted into the 64-bit ciphertext block using the data encryption standard. These are some other version of the DES. Double DES, triple DES. So double DES is suffering from the problem of man in the middle attack. So the known secure version of DES is the triple DES. So we can use the algorithm 3 times for triple DES. Okay. So triple DES could be with the 2 keys. Triple DES could be with the 3 key also. So this is an example of 2 key triple DES where we are taking K1 and K2. And K1 for encryption, K2 for the decryption process. So this is the triple DES. We can improve the security by using the triple DES, but speed will be, obviously it will be slow version of the DES, but it will be the secure version of DES. Are you getting my point? So this is the triple DES. Now let's move towards the stream cipher. This is an example of block cipher. DES is an example of block cipher. Now move towards the stream cipher. We know that in stream cipher, it is the continuous process, and we are generating the K stream from the K. we are combining or XORing the plain text bit by bit with the key bits. Okay. By this example, you can clearly see the structure of the stream cipher. The K is there by using K stream generator. We are generating the stream of the K and we XORing the K stream with the plain text stream. Okay. This is the pseudo random number generator. What do you mean by pseudo random number generator? What do you mean by what is the difference between pseudo random number and random number generator? Pseudo random number generator, it is a random but not purely random. That means for pseudo random number generator, we are having a seed values, the initial value. That's why it is not completely random but random. So by using some pseudo random number generator, we can generate the K stream from the key K. And we are continuously generating the small k represent the K stream, the capital K represent the key. And these K stream will be XORed with the plain text bit stream. So in this way, we can get the ciphertext byte stream at the side of decryption. Same pseudo number generator will be used and it will generate the same K stream. And this K stream will be XORed with the ciphertext byte stream. And again, we can find back the plain text byte stream. So this is an example of stream cipher. Popularly known method for stream cipher is the RC4. RC4 that means RC4 R means the rivest जो RSA में R हैं person वो R उन्होंने security field में they have worked a lot. So on the name of the rivest it is R. C for cipher, rivest cipher 4. It is an example of stream cipher. So on the basis of key, we have classified the encryption into two types. If you can see my previous slide, so symmetric and asymmetric. We have discussed the symmetric cipher. Then we have discussed the block and stream cipher. We have discussed the substitution and transposition cipher. Now let's come to the public key cryptography or the asymmetric key cipher. So this is an example of asymmetric cryptography. Visible है ना? Is it visible?
Yes, ma'am.
Thank you. So this is an example of asymmetric key cryptography. You can clearly see the difference. In symmetric cryptography, there was only a single key. That key is shared between the sender and the receiver. But in the asymmetric key, the receiver and the sender is having a key ring. That means a pair of key, a public and the private key, and the public and the private key. At the both sides, sender and the receiver, they are having a pair of key. Okay. Here I have drawn the public key ring. Suppose this is a Bob. Okay. And Bob wants to send the message to Alice. Okay. So Bob is having a public key. Suppose Bob wants to send a message to Alice. So what happened? Bob will encrypt the message by using the Alice public key. Public keys are shared between sender and the receiver, but not the private key. Private key never ever shared between anyone else. Okay, only public keys are shared. So if Bob wants to send a message to Alice, Bob will encrypt the message by the use of Alice public key. So Bob can send to whom Bob can send the message? Bob can send the message to Alice, to Ted, to Mike, to Joy. These are the list of authorized person to whom Bob can send the message. Okay. And Bob can share the public keys with these authorized person. So now at this time, Bob wants to send a message to Alice. So what happened? Bob will encrypt the message by using the Alice public key. At the side of receiver, Alice will decrypt the message by Alice private key. So it's very simple. If Bob wants to send a message to Joy, Bob will encrypt the message with Joy's public key. Okay. At the end, at the side of receiver, Joy will decrypt the message by his or her own private key. Are you getting my point? So this is the concept of asymmetric encryption where the sender and the receiver are having a pair of key. So we generally heard about the encryption and decryption by using the different cryptographic method. Specifically for the public key encryption is not only used for encrypting and decrypting the data to provide the security, but public key encryption is used for some other applications also. Okay. So for other applications like digital signatures, like key exchange, so public key cryptography can be used for encryption and decryption as well as it is used for the digital signatures also. It is used for the secure exchange of key also. So these are some other application of public key encryption. First application of public key encryption is the encryption and decryption to provide the confidentiality. Second application of public key encryption is used for message authentication. Now, what is message authentication? That means message is coming from the legitimate source and the protecting the integrity of the message. So, what is the objective of message authentication? The objective of message authentication is to protect the integrity of the message, to validate the identity of the source, to validate the identity of the origin or the source. You know? After sending the message, sender cannot deny. So this is the objective of message authentication. There are different alternatives used for the message authentication. The message encryption, in message encryption, the whole ciphertext is work like authenticator. But if we are using message authentication codes, so message authentication codes are used for the message authentication. The hash functions are used for message authentication, right? So we can say that it is an example or it is an application of cryptography for message authentication. Different type of security requirements for message authentication. So what is the need of message authentication? If I say ki what is the need, what is the requirement of message authentication? So we want to save our message from disclosures. Disclosure, that means unauthorized access of message. We want to save our message from traffic analysis by passive attacker. We want to save our message from masquerading. Masquerading means if the attacker is pretending like someone else, this is the masquerading. If we want to protect our message from content modification, if we want to protect our message from sequence modification, if we want to prevent from timing modification, we want that source repudiation should not be there, destination repudiation should not be there. So to fulfill all these requirements, what can happen? We can use the authentication process for secure transmission. Okay? So message authentication methods, there are different type of methods used for message authentication. First method is message encryption, where the ciphertext of entire message will serve like the authenticator. If we are converting hello into some its corresponding ciphertext form, so whole ciphertext will be act like a message authenticator, right? Second method is hash function, a function that maps a message of any length into the fixed length hash value, and these fixed length hash value will be work like a authenticator. Okay, we can take the variable size, variable length of message, but from this variable length message, we are converting this variable length message into the fixed size hash code or fixed size hash values. These fixed size hash values will work like a authenticator. And third technique that is used to message authentication is the MAC. MAC is nothing but the message authentication code, a function of the message and a secret key that produce the fixed length value. Now the question is that what is the difference between the hash functions and the MAC? So difference क्या होगा यहाँ पर? The difference is that to calculate the message authentication code, we need a secret key also, whereas hash functions doesn't need the key value. So this is the message authentication code. This is an algorithm that required use of secret key. A MEC takes a variable length message and secret key as an input and produce the fixed length authenticator code as so this is or tutorial representation of authentication. In first, symmetric encryption is used as an authenticator. In first diagram, you can see that this is the message. This is the method by which is converted into ciphertext form. This whole ciphertext is work like authenticator. The side of receiver B will decrypt the message by using the same key. So this is the authentication through the symmetric encryption. Okay? This is the authentication through the asymmetric encryption. You can convert into the using the public key of receiver. Will decrypt the message by using the private key of C. So this is the diagram of public key encryption as an authenticator. And this is the third diagram where we are using authentication by using private key. We are converting the message encrypted form by using the private key of receiver. Okay, and we decrypt the message by public key of the receiver. So these are three different examples for authentication, like how encryption is used for the authentication. So these three examples show how the encryption is used for the authentication. Moving towards the digital signature, as I told you that, am I audible now? Audience, I am audible. Am I audible?
Yes, ma'am, you're audible.
Screen is visible?
No, ma'am,
My screen is visible?
No, ma'am.
So please let me know if any time my screen is not visible to you. Please let me know. Which slide number is the content?
Slides are not visible.
Visible? Now it is visible?
No, ma'am.
Not visible?
No, ma'am. Now it's visible. Now it is visible, ma'am.
Okay. ठीक है. Previous slides You have how many slides you
Visible
have
now,
missed? I
ma'am.
don't know. Okay, fine. So digital signatures. Okay. So how the digital signatures are how digital signature use the encryption methods. So and the objective of the topic is that encryption or cryptography is not only used to encrypt or decrypting the message, but it is used for different applications also. Okay? Like it is used in the message authentication. Okay? Uh, so digital signature is another example or application of the encryption. We know that digital signature used in the situation when there is not a complete trust between the two parties. If sender is sending the message to receiver, and after sending the message, if the sender is denied that I haven't sent the message, or after receiving the message, if the receiver denied that I haven't received the message, so this is the situation of the dispute. To overcome the dispute situation, we can use the digital signature in this particular situation when there is not a complete trust between the two parties. Are you getting my point? So digital signatures use the cryptographic mechanism that is used to verify the authenticity of digital data. Okay, that can be used for many purpose. Digital signature can be used for different purpose. We can use the digital signature to sign the document, and we can use the digital signature to verify the integrity of the software. We can use the digital signature to validate the online transaction. We can use the digital signature for some legal proof. So this is the diagram of digital signature. How the asymmetric